This is a work done by me and other people in the area, and also Mr. Leotta, that is CEO of Microtech, is a company that work with us in the electronic fields. So also for me, so it's mandatory the slide presenting the company. It's a company established in 1975. We make security doors, so it's a really the door that you may have in your house, and this is some number of our company. Our systems are made in Italy, or the mechanical components and the electronics. In 1998, DR was one of the first companies in this sector to bring on the market a security door with a complete electronic lock. And now in 2020, we are working in our last project that is called Next Electra. It is a door with electronic lock, with Bluetooth and internet connectivity, which is the one that I'm going to present, and it is done in collaboration with Microtech, that is SME in Italy, in Tuscany. So first of all, I concentrate on what the statement of the conference is saying about the contribution about companies. And so I'm really not going to speak about low-level technologies on the algorithms, because here we make doors mainly, but I want to share you the requirements that are present in our system, because as I'm going to show you, cryptographics are everywhere in security doors, and not always. The actual security algorithms and schemes are very suitable for this sector. So just another point, I'm going to speak about doors and keys, but a lot of you may think about doors like this one, that is the 8080 doors of TCP protocol, and keys are the encryption keys. No, I'm mainly speaking about doors that are the door that you're using to enter in your house, and the keys that the one that we insert in your lock. So, but I'm let's say proud to work in a sector that is the sector where the words doors and keys are born. Let's start to the scenario. So this is a sector where the technology is really becoming more and more important. In the 20th century, let's say that the problem of opening and closing the door of your house was very, let's say, very simple. So if you have the right key, and I'm speaking about the mechanical key, then you can enter in your house. If you don't have the right key, you stay out. As you know, there are a lot of tricks in mechanical systems that can implement complex hierarchical access, such as the ones used in the hostels, where one key can open different doors, and you have a hierarchical scheme that you can use to open the doors. But this is something that was valid until the 90s of the previous century. What happened now? Now you can see that the users start asking for something new. For example, some user want to enter in the house, even if they don't have the physical, I mean mechanical key. So if you have your smartphone, you have your finger, your face. So this should be enough to enter in your house. Maybe you want someone that has your physical key not be able to enter. This is another problem. If you lose your key, or someone stole your key, you don't want that people to be able to enter in your house. Another point, you may want someone who has not your physical key to be able to enter in your house. If you are If you are a host of a bed and breakfast in the mountain and you want someone to enter in your house and you are not there, you may want to be able to send a virtual key to that people to enter in the house, even if you are not there. And also other strange things like domotics and so on. So you want to open the door just saying hello to the door and so on. What happened between these two scenarios is that the first solution of automatic and electronic door opening were come from the car segment for the car application. So as soon as the people start to be able to be used to open the car with not only the mechanical key, they also want to use the same mechanism in your house, in the house. So this new scenario brings to solutions that are implemented in the security doors that are quite complex. And I'm going to show you briefly what I'm talking about. So first of all, the mechanical key that we were talking formerly should be always a way to enter in your house, because it's good to trust the electronics, but may happen that you have let's say blackouts or something like that. So to have a backdoor to enter with your mechanical key is always a good solution. So even if now we are going to speak about complex electronics locks, you have to think that always the mechanical opening option is always there. So what happens next? People want to enter with a smartphone on their house. So this will allow the implementation of most of the things that we were discussing in the previous slides. So we use in our system, we have applications running on a smartphone that dialogue with the lock of the door. And via this communication, the user is able to open and close and to see all the door status and to see all the door statistics and logs and so on. We are using here in the area the encryption and the encryption schemes that are standard in Bluetooth. So we are not using custom algorithms because the market is quite big, and we want to be sure that the security of the scheme that we implement is good. We are part of we follow really tight the security expert group work in Bluetooth, so to be able to follow all the if there are issues or something like that, we want to stay update. What is the disadvantage of this approach is that mainly the pairing operation that here we are all technical guys, maybe something like that is really easy to do. The pairing of the Bluetooth device, the smartphone with the door, is an operation that depends on the operating system of the smartphone, because it's there that this level of the link lay is established. So it is not a really standard procedure, and many users don't want to wait and to have trouble in pairing devices with the door. But anyway, we think that having the pairing provided by Bluetooth is the best way to avoid the man in the middle and all the other attacks that can be done on the Bluetooth channel anyway. Another step is this one, is people want to use biometric system to access the door. and it's something related to the previous talk. What is the drawback? Is that this kind of sensor, like fingerprint sensor, are placed on the door panel, on the outside of the door panel, and are really with a really easy access from the outside. This is because people want to authenticate from outside, obviously. But also in this system, usually the matching algorithms and sometimes also the database of the finger is in the memory inside the sensor. So what is the kind of attack that people can do in this system? A potential attacker may try to go to a store and buy another fingerprint reader as a replacement part for that door, and may be able to register his finger and substitute the fingerprint reader on the door and enter in the door. So for this reason, the communication between the fingerprint reader or let me say all the other kind of sensor that works in this way and the central unit of the door must be at least authenticated. I will say encrypted and authenticated to avoid the substitution of this unit with a tampered one. The last step is the one that allows the completely remotely management of the door. In this way, we want to be able a host. You can see my pointer here. The host will be able to send up the virtual key to a guest that want to access to a door that is placed remotely, let's say in a mountain. So what is the procedure? The host sends this virtual key to the guests following this pattern. The cloud platform is storing the credential and the virtual key. So as soon the B&B, let's say, for example, guest approach the door and want to open the door, they ask access to the cloud platform. And the cloud platform is, if everything is okay and if the private key is valid, send over this channel an authentication command. In the field, we have a bridge that is able to connect Wi-Fi or LTE, whatever you want, from one side and Bluetooth on the other side. So there is a kind of authentication command and the opening command that comes from the cloud platform directly to the door to open the door. Also, you have to think that sensitive data such as credential and data of the guests and the host, and also the opening and closing time is all considered sensitive data, so it must be encrypted on the cloud platform. So imagine that the bed and breakfast guests want to open. There is a quite tricky path to follow for all the authentication system to work. So I mean, what is called the push to open time is very critical, because if you are in front of the door and you don't know all this kind of infrastructure, you just want to open your smartphone, push a button, and see the door that is opening. And if you are on mountain and it's -10 outside, you want this happen, let's say, in less than 5 seconds. Okay, this is the conclusions. Even if the door opening scenario may look simple, it has hidden some very tricky constraints, and this is the one that we discuss in the presentation. The other constraint is that the door has an internal battery, and if in case of power failure, all the system must run in low power mode. So You cannot afford to have inside the door, such as power processor, PGA, to run complex algorithms. So all the encryption that is carried out inside the door system, inside the lock, must be low power. So you have both constraints in terms of power and in terms of time, running time of the algorithm.